AMD's Advancing AI 2026, and there are robots now? Why are there robots? So AMD had their Advancing AI 2026. I mean, yeah, they're launching a new AI stuff. It's like we get to hear about the new Instinct GPUs. We get to hear about Zen 6. Those are both launching to customers right now. They already shipped to Microsoft and more customers through the next half of the year. But robotics may be the most unexpected part of the entire show. It's effectively Strix Halo. Strix Halo repackaged for machines that move through the physical world. A large unified memory pool. It's AMD CPU, RDNA GPU, NPU compute, but it's also paired with AMD's FPGA, which is wild because I lamented that the Ryzen AI Halo needed that at launch. Well, here it is. The Kira AI system on module powered by Ryzen AI embedded X100. It's Strix Halo's basic proposition, one large coherent memory pool, but now for robots. And AMD was demoing humanoid robots as well as four-legged robots. Kira for the brain, Versal for the spine, Zinc for the joints, and Spartan for the sensors. That's more or less a complete robotics platform. It reflects different timing requirements that you need inside a robot, and the vision language model might decide that, this needs to move this or this needs to move that. But the FPGA gives you a lot of options for customization and building. And there were a lot of partners here showing, hey, we're already doing this with our GMK Tech Strix Halo boxes. This is going to be the next best thing. Great Asimov's Ghost. This is the unironically named foundation. They have 1,000 of these robots in production already, or deployed in factories, or in the process of being deployed in factories. And it's real AI. The GMK Tech Strix Halo, that's what this is running off of. Just like the one that we have. The future's coming fast.
Hey, I'm Greg. I'm a field engineer at Foundation. This is Phantom Mark 1. It's our humanoid built specifically for heavy industrial use. We're the biggest and strongest humanoid robot on the market. We target specifically industrial logistics use cases where humanoids are lifting and carrying heavy objects. So one of our automotive customers has all these hot presses around the factory, and we've seen one of these blow up and cover a human in hot plastic while we were deploying a robot in that same factory. And so we could basically protect for those situations by having these robots cover these dangerous roles in those environments. That worker was wearing PPE. He turned out to be okay, but it was a very dangerous near miss for that company.
AMD claims third-party testing against NVIDIA's Jetson Thor showed 3.4 better real-time results and 2.3 times better concurrent results with running multiple agents. And it is more CPU horsepower. I mean, we know that from the 16-core Strix Halo testing that we've done. So it's interesting. It's interesting that AMD is positioning it this way. I love this because there's more people here than AMD expected by a lot. There's a lot of people here. Definitely more than 10,000, but I don't know how much more than 10,000. AMD did the best job, in my opinion, that they've ever done with the keynote explaining what they're launching. So you should go watch that. There's a lot of good information there. It's good information density. AMD formally launched the 6th generation EPYC family based on Zen 6, including a 256-core Zen 6C part. It also introduced PCI Express versions of the MI350, the MI350P, intending to bring 144 gigabytes of HBM acceleration to relatively conventional air-cooled enterprise servers. It also disclosed MI455X. That's CDNA5 architecture, and it's and we got some substantial detail about that, which I think is going to be covered in other videos from other channels like Chips and Cheese. You should check that out. And Helios packages Zen 6, 72 MI455X accelerators, HBM4, and AMD Pensando networking into a complete rack scale system. And that is already shipping to customers, and it's going to ramp through the last half of this year. The recurring message from AMD was that AMD no longer wants to be isolated to CPUs or even CPUs and GPUs. It wants to sell, or at least define, the complete machine around them. And Helios looked pretty interesting. This is the back of Helios. This is like $5.5 million of gear. It's just, Helios is a lot of compute in a relatively small form factor. Now, it is a new form factor. It's wider, a little higher volume. I think they said that each one of the compute drawers was like 170 pounds. You're going to need a lift gate, but they've designed it with better serviceability in mind, so you don't have to take the drawer out in most scenarios. Helios is the point where AMD's AI strategy becomes a credible rack scale product. I mean, 72 MI455X, 18 high-frequency Zen 6 EPYC CPUs, and roughly 31 terabytes of HBM4. The GPUs form one scale-up domain with an aggregate 260 terabytes per second of scale-up bandwidth. AMD is using UA-Link over Ethernet for the accelerator fabric. Each MI455X provides 3.6 terabytes per second of bidirectional scale-up connectivity. Each GPU can connect to as many as 3 Pensando Vulcano 800 gigabit AI NICs for scale-out. The physical switch layer still depends on outside silicon, the Broadcom Tomahawk 6.
Now, if you look at the hardware breakdown of Helios, it's telling a much more coherent story about AMD's planning for networking integration, the GPU, like data processing for data ingress and egress out of the compute cluster, and how they plan to connect the GPUs together. But also, Broadcom Tomahawk 6 is still a big part of the story here for their interconnectivity. But they're leaning more into Pensando, and Pensando for DPU, and Pensando for internal networking, and Pensando for a lot of other communication aspects of the cluster. And I think the story that they put together in terms of like, this is what we're using for Helios, it is also a lot more believable, because it's like, okay, we're using these things from the industry, which are, best of breed solutions, plus also this is how we're integrating our own stuff and stuff from our portfolio. And that's how we see it, coming together. And it's already come together in that form for customers like Microsoft. And we heard from Lisa Su that, yeah, this is ramping now, and customers are getting it through the end of the year, and into Q4. So.
But AMD is increasingly owning the endpoints and the data movement around the fabric through Pensando, Vulcano NICs, Selena DPUs, and the Infinity Fabric protocol carried over the UA-Link Ethernet, which is, by the way, an open protocol. So good job, Ethernet Consortium. And shipping to Microsoft with the announced Microsoft partnership, Helios is extremely not theoretical. It seemed like AMD was also hinting that Meta and Oracle and Anthropic were already validating racks in addition to what's shipping to Microsoft now. That's a large-scale AI platform with real customers. All right, so the MI455X is more interesting than the headline flops numbers suggest, which are quite good. CDNA5 replaces Wave 64 with Wave 32. Wave 64 is deprecated now. That cuts the execution group in half, reducing the penalty when threads take different branches, lowering register pressure, and reduces instruction latency. It is particularly useful for irregular, latency-sensitive kernels, which have become increasingly common in inference. This is a similar direction that AMD took with RDNA, and so in a lot of ways CDNA5 looks a little bit like RDNA, and I wouldn't be surprised if this is why early on AMD might have been referring to this as UDNA. I mean, RDNA separated work into smaller Wave 32 groups to improve utilization and make the architecture better suited to modern graphics and gaming. CDNA5 now adopts the same basic execution width because AI workloads increasingly have many of the same scheduling problems. That doesn't really make CDNA5 and RDNA type gaming architecture, but its memory system, packaging, matrix hardware, interconnect, and the reliability features are all designed for rack scale compute. Like that's CDNA, that makes sense. But the two architectures kind of are converging on some of the same answers about how work should be scheduled. So I think that's pretty interesting. AMD says peak MXFP4 and MXFP8 performance is 4 times an MI355. We're talking about 40 petaflops max. That's pretty crazy. On DeepSeek V4 Flash, AMD showed approximately 4 times the MI355X throughput at low concurrency, and as much as 34 times in the highest tested concurrency. The downside of this, though, is that for this to be useful, the smallest useful unit of this thing is the entire rack. So, MI350P for things, when you need less than a rack, it's going to have to be MI350P.
So that wasn't the only big set of announcements from AMD. There was also Hyperloom. AMD is kind of leaning into, okay, we're going to build all of the infrastructure and we're going to build all of the stuff to automate helping build math kernels to do things better on our hardware. Here's our full published specifications for the hardware. That's open source. That's always been a big part of AMD's strategy. We're going to publish open specifications, open hardware, open everything else. That's why GeoHot was here, George Hotz. It's like talking about trying to make the ecosystem a better place, publish specifications. But because the specifications are open, you can turn sophisticated models loose with it and build the software. And that is why we are seeing a rapid improvement in AMD's software ecosystem. Incidentally, this is also why CUDA is really not much of a moat anymore. You can take the most fancy, amazing, beautiful, brilliant CUDA code
and say, I need you to adapt this to this hardware that fits this specification. And that's really not that much of an uphill climb, not nearly as much as it was a year ago. A lot of the other thing that's going on here is the AMD developer zone stuff. So like if you're a developer and you want to connect with the actual developers or help people troubleshoot, this is really good because AMD gets to experience firsthand the kinds of issues that people run into and questions they have, which will help reshape content. But also if you're a developer, here's a session, here's a breakout of how you can do things and put things together. They have the Luminary talks, sure, but this is also developer workshops. It's a different thing, but it is very nice to see this at this event. And like 10,000 plus people here, they're getting a pretty amazing knowledge download. I'm at Advancing AI 2026 and look who I ran into, it's Donato.
Hello.
If you use Strix Halo, you probably use his toolboxes. You have done a great service for us all. I have used the crap out of your toolboxes. It has made everything amazing.
Thank you very much. So yeah, I'm here at Advancing AI, and it looks like AMD also noticed my toolboxes. That's been my hobby project for around 1 year now. I actually cannot believe it. It was almost 1 year ago, at the end of July 2025, when I published the first version of the toolboxes, and I would have had no idea that I would have ended up here in San Francisco at AMD Advancing AI.
Did you think that we would ever see this level of performance from, like think about when Strix Halo launched and it's like, okay, I'm getting like 5 tokens per second, but now?
Oh, the tech stack has improved so much since then. Like it's day and night. I mean, kudos to AMD for all the work they put into ROCm. This is now a considerably better supported platform than it used to be just 1 year ago.
Yeah, so right now we have, Vulkan, obviously, but also ROCm. And even like the ROCm 7.14 release that just happened, they're really doing a lot of things differently. There's a compatibility matrix now that they publish on their website. And the compatibility matrix is like, okay, here's RDNA and then Strix Halo, which is another different flavor of RDNA, and all the stuff that goes with that. Yeah, it's an entirely different world than it was a year ago. Just not in terms of performance, but also just in terms of developer ecosystem. And you still have the Vulkan fallback if you run into problems.
Yeah, but that's the thing that I really loved to see. Like the entire stack was updated. Even the way the stack is built, like all of the ROCm build systems and pipelines were completely redone from scratch. Like now, if you want to contribute to ROCm, it's completely open source. If you want to contribute or even build your version locally, this is much simpler. And now if you want to learn how that works, you can just take ROCm and see, okay, that's how like an enterprise stack works for this kind of stuff.
It's also changed because we had ROCm, and then we also had like the ROC, and the ROC was more for people that were not using CDNA, Strix Halo and RDNA and everything else. And now it's like, oh, they seem like everything is sort of merging together. Although I think some of your toolboxes are based on ROCm Nightly, right, which have good support for everything across the board.
Well, so those toolboxes based on ROCm Nightly, it was because at the very beginning, when Strix Halo was launched, you didn't really have good support in mainstream ROCm. I think 6.4.3 or something did not have support. So if you wanted the best performance, you needed to use the builds from the ROC or the Nightly builds. Like there was no other way to get the good performance. But now the stable versions of ROCm perform very well. So I still use the Nightly builds from time to time, but I recommend that people actually pick the latest stable version because that works just fine.
Nice. Well, there's a lot more at Advancing AI in 2026. We'll take a closer look, and you'll probably see him floating around in the background.
That is mean. That is really mean.
The robot's putting the RAM in the server, but it's powered by Strix Halo. Look at that. It's a GMK Evo.
That's where all the RAM went.
The robot's loading the RAM in the system via Strix Halo with a webcam. Okay.
Hey, my name is Soresh. I'm from Luma AI, and we're currently at AMD Advancing AI 2026. So for context, Luma AI is a video generation company, and with these types of pipelines, we serve a lot of incredibly complex models. And AMD's hardware, with their very high bandwidth interconnect and their incredibly large amounts of VRAM, are what enable us to actually, perform these large-scale inference workloads
for all of our customers. So imagine you and your buddy are just in your backyard trying to cosplay as knights, and you're swinging around some sticks or something. You shoot that on an iPhone, give it to our video generation model, and then it'll essentially reimagine the scene from the ground up while preserving the structure and motion from the original input video. So the goal here is that for creatives, they get a lot of additional control over that end output versus just giving it like a text prompt saying, give me 2 knights from like the medieval era. You actually get to kind of show like the choreography of like the knife, of like the sword play and whatnot, so.
Look who I ran into at Advancing AI. It's Micro Center. It's probably true that I've helped put at least 1, probably 2 people's kids that work for Micro Center through college just with all the crap that I bought. But they're showing off because it's like, hey, you can buy AI Halo, you can, Strix Halo machines, and you can buy the R9700 from Micro Center. So let's check it out.
Hi, I'm Jacob. We have tons of R9700s and AMD AI Halos here for sale. And you don't even have to go to your local Micro Center. You can do it right here in San Francisco.
I'm in the background being distracting. This system is actually running the MI350P, although it's not currently actively running a workload because we need the side of the computer to be on because of the airflow and everything else. But this card has 144 gigs of HBM3. It's a very, very fast card. Very absurd. So AMD is showing some benchmarks here, some real world benchmarks. And this is entering regular old availability pretty soon. Although with 144 gigs of HBM3, it ain't gonna be cheap. Sorry, 147, 146, somewhere through there, gigabytes of HBM3. The MI350P, I need 8 of them. I need 8 of them. Let's see, 8 times 15, $20,000 probably. That's a lot. Gorgon Halo, a little bit of pre-release, but these are framework systems that are here. 192 gigs of VRAM and a Gorgon Halo cluster around the Intel E810. It's launching soon, like kind of soon, pretty soon, but 192 gigs of VRAM cluster, DeepSeek V4 flash on something like this, I mean, 192 gigs of RAM is basically already unobtainium. So with these, it's gonna be crazy, crazy limited availability, but they're here, it works, it's something to behold. Everybody needs it for local AI. This is what we need to be able to run locally. I don't want to run this stuff in the cloud. I want to run it on my desk, and this can do it. And I'm here with Carlo. I used your FP4 stuff, which is awesome. AMD brings everybody together so we can talk about things, and you got to show off some stuff that you've been working on and all kinds of fun stuff. And there's going to be a lower third with a link to your projects and stuff. But here, let me give you the microphone so you can be excited about the stuff that you're working on.
Hey, what's up, man? First of all, nice to meet you. Really love your stuff and the way you explain. Yeah.
Internet rando.
Yep, internet rando. But ROCm FP4 and ROCm FPX, I just love tech, and I was like, we need something that runs fast in Strix Halo, and I made it. Took 21 hours, and it's out there in the wild, and the community loves it, and AMD's like, come to the event, so I'm here.
Yeah, I like this because one of the things that they showed at the event was the Rubicon has been crossed in terms of the AI. I don't want to call it self-improving AI, but that's not really a super inaccurate way to describe it. It's like, here is what we have in hardware. Here is what we would like to accomplish. Make it go. And the AI is smart enough to make it go. But it still needs supervision of people that know what they're doing.
Yes, I agree with you. It's all about the optimization, the software on the hardware, because a lot of times vanilla software is not optimized. So it's all about the optimization.
Yeah, cool. So check that out. And if you want fast FP4 on Strix Halo and RDNA and everything else under the sun.
And one of our patches, High 3, got accepted into mainstream Llama, and Laguna S 2.1 is now in there, running about 40 tokens decode on a Quant 4.
This is what we need for local, accessible, offline-ish AI. Cool, thanks.
Awesome.
Hi, I'm Jeremy from AMD. I'm a maintainer on the Lemonade project, which is a local AI solution, like really easy to install, get up and running on your AMD PC with LLMs, image generation, speech generation, all kinds of different fun stuff.
So that's 9070, 9060, Strix Halo, 64 and 128 gig version. Well,
right.
even the 32 gig version.
Oh yeah, all the way down to like a Kraken Point laptop will get you up and running on your neural processing unit on that, running LLMs on there, like 3 watts. Yeah, and we're here. We've got a bunch of the Lemonade community. Everybody flew out, so we had a big meetup yesterday. Yeah, it's a very community-driven project. So we had a big old brainstorm for a few hours in one of the conference rooms upstairs, and yeah,
one thing I love that what AMD has done with this event is basically, if you have been working on anything related to AMD, they tried to reach out and it's like, let's get people together, let's work, let's try to figure stuff out, let's put people together, let's put everybody in the same room and do some fun things. And Lemonade has come a long way, and it's been amazing to watch. Because in the beginning, I think it was more focused on the NPU. I don't know. I mean, that's just me.
That was the first thing, yeah.
Yeah, and then, but now it's like, oh, you can use this as a back end for other things like Turnstone or other tooling or Hermes or whatever. You just Lemonade in the back end, share it on the network, and then boom, you've got an agent that's running local.
Oh, exactly, yeah. So we're not like trying to keep you like in our app. You know, we're not trying to be this thing that like people use directly every day. We want you to kind of like set it up as a service on your computer. And then we've got this marketplace that you click into, and it's got like anything LLM, Hermes, open code, ton of different apps that can use the tokens and images and everything being produced by Lemonade. And that's, you know, those are the great user experiences, and that's where we think people will be, you know, spending their time.
Make it easy to do the thing, and it's local.
Yeah.
I'm all about local AI.
Exactly.
Run it locally, download the model, do the thing. That is the future. Open source is the future. Remember these words. Open source
is the future. Yeah. Awesome.
All right, thanks.
All right, thank you so much.
I found somebody that's super into benchmarking and data, and I like that because now I have a reference.
Yeah, so that's the thing about local AI. You've got so many choices. You get to quantize them yourself. You've got so many ways of doing things. So I spent probably the last 3 months all my time on the AMD platform, the Strix Halo in particular, looking at every way I could twist it and turn it to get every ounce of speed out of it. So I've been developing several models, tend to get significantly better quants. My Hugging Face is JCBTC. You'll find my models there. I've got a page at llm.shiru.ai. That's you'll love it. I've got of course, pre-fill, token generation. I've got the tuning lab where you can see all the different knobs and how they affect the model, different quants.
Benchmarks?
I do Hermes 20 benchmarks. I've got like 100 of those, 100 different models. Sometimes if you go to my research page, actually, I get deep into how, like every time it loops, for example, I literally created a sandbox and investigated the loop per token, looking at the percentage of each next token and trying to find out why it was happening and how I could stop it. I get like
accomplish this task, but it costs too much. You get a demerit point.
Yeah. So it's been a lot of fun though, and I love, you know, I mean, anybody doing local AI stuff is that's the future to me right now. It's freedom, man.
Yeah. Well, and you know, we're going to have to make the AI run well with the limited hardware we already have. And we're getting there. We are so getting there. It's getting close. It's getting exciting.
And every time a new model comes out, it's like you get a free upgrade.
Yeah.
It's like your same hardware now is like twice as smart.
Yeah, yeah. And we're getting where you can do productive things even with like 16 gigabyte GPUs, like an actual useful model for dev and everything else. So,
even Laguna.
Yeah.
It's running. I saw it on a 12 gigabyte model now.
Fun times.
Yeah.
Fun times. So check that out.
Cool, man.
Now, for AMD's side of the software, they spent a pretty good portion of the event talking about ROCm, Hyperloom, and ROCm.ai. Now, Hyperloom is sort of interesting, but the concise version is that AMD is taking advantage of something NVIDIA cannot reproduce as easily. Much of AMD's compiler, kernel architecture, and documentation is available in the open. It allows designers and developers, and now increasingly coding agents, to inspect the entire stack, identify missing optimization, generate a kernel test, contribute the result back upstream. AMD says Hyperloom recently processed and optimized a suite of 14,000 models. In the keynote demonstration, it improved one Minimax M3 configuration by 38%. But the more convincing evidence is not the stage demonstration, it's the community that has formed around this, because that's demonstrating that the community actually exists. And if AMD releases ROCm.ai and is generally available to this community, then the CUDA moat goes away. Zen 6 Epic Venice. It's launched. It actually launched like a week ago. This one's a little bittersweet. AMD says its 6th generation Epic is in production and that OEM and cloud rollouts begin in the 4th quarter. But based on essentially every system provider I spoke to, while obtaining meaningful general purpose availability, is probably going to be later than that. Customers are pre-purchasing production capacity. So when will we get our hands on a Zen 6 system. I don't know, but check this system out.
Okay, so this rack behind me is legit. This is Venice. There's 43 compute trays in here, but each one of those trays actually 2 nodes. That means there's 1,024 x86 compute cores in one of these. And we have 42 nodes in this, 42,000 x86 cores in a single rack.
Yeah.
This is madness. This is madness. The meme that brought AMD back, where it's just the guy in like the clown hat, and it's like, I need more cores.
Exactly. Yeah. So for all the HPC applications, this is this highest density solution. Yeah.
And so the idea here is that your agentic workload, I need 4 cores, I need 8 cores, I need 16 cores. You spin up a little container, and they're running here.
Yeah. Yeah. That's correct.
It's madness. They've got local storage, looks like some E1 local storage.
Yes.
And it looks like you've got some QSFP networking down here for your example.
Yeah.
So
and there is switch integrated into the rack. Yeah.
Nice. Yeah. So and this is the open compute form factor.
1 OU. Yeah.
1 OU unit.
So this whole rack is 48 OU.
48 OU. Yeah.
Yeah.
That is a serious amount of x86 compute in a really small package. What's the maximum memory capacity?
So you can support 256 GB DIMMs. So total you can go. We just did the math. 688 terabytes. If you populate all the DIMMs with the 256 GB DIMMs, you can go up to 688 terabytes.
It's the GDP of the planet if you actually want to buy that much memory right now. But yeah,
exactly.
But there you go. That chassis, that's the Supermicro Flex Twin, and there's more compute capacity in this one rack than many data centers have. I mean, you've got 1,000 cores per node. Well, not even 1,000 cores per U. So it's pretty nuts.
Yeah.
And the NICs, those are Polara NICs. Polara 400 gigabit.
43,000 cores in one open compute rack is mind-boggling. But there's actually 4 different configurations of EPYC that are launching at different times. The 96-core high-frequency part is built to host GPUs. It runs at frequencies approaching 5 gigahertz, up to 5 gigahertz, and appears in each Helios compute tray. The 128-core version targets conventional, enterprise, and general-purpose servers, and then the 256-core Zen 6C monster 512 hardware threads in one socket, aimed at dense agent execution. And that is the one that... it was also NVIDIA's increasingly serious server ARM ambitions, and so NVIDIA released their spec-int benchmarks, and AMD's got their spec-int benchmarks, and AMD says, well, we're 20% higher. So that's pretty exciting, and it probably makes NVIDIA just a little bit nervous. But we'll see. We'll run the benchmarks. We'll see. AMD says Zen 6 doubles the memory and I/O bandwidth relative to the previous generation. That means that we've gone from 12 memory channels of DDR5 and to 16 memory channels in PCI Express Gen 6. And there's also a version they're promising that has 24 channels of LPDDR5, but we'll have to wait to get some more details on that. So AMD's Advancing AI 2026 is not really a GPU or a CPU launch for every man. This is stuff that's for the enterprise, the highest echelons of compute. And yeah, you'll probably be able to rent time on these machines in the cloud, but it's not something you can really get your hands on. And yet, this hardware will unlock software all the way down to the most modest system. Existing systems based on Ryzen AI Max, Strix Halo, Gorgon Halo, everything and beyond, the entire software stack is going to benefit from the intelligence that's running on these machines. The hardware exists, the racks are running, and the developers are here. There's a lot of excitement. And now AMD also has robots and a robotics platform. So that was fun to see.
Did you know AMD is an F1 sponsor? Yep.
I'm Wendell, this is Level 1. If you have any questions or I miss anything, I'm signing out, and I'll see you in the forums.